we are live. So we were working on the GPU mesh, the refactoring, compiling obviously fails. Yep, quite a bit of errors. So handle this in a better way. Yeah, what's the problem here? The problem here is that we basically have duplicated all this duplicated code for nothing, very error prone. Changing one thing, you have to change it in 3 places, very messy. So the idea is that just do this for int I less than this I plus plus, and that is that we take the description. Oops, but do it this way directly. So we take the buffer desk, CPU mesh, the vertex count. Okay. So the size of this buffer is the number of vertices times mesh get float per vertex I times size of CPU mesh vertex buffers I 0. Take the ith vertex buffer and then I simply take the 0th, the first element. Okay, that will be a float, so 4 bytes, 4 bytes for every component, and then for every vertex. It's immutable. It's a vertex buffer, no CPU access, no MISC flags, no structured byte strides. The subrest data is the CPU mesh dot vertex buffers I dot get. Voila. Sysman pitch 0, useless. Now the mesh dot vertex buffers I equals that's a problem. Vertex buffers, that's a problem. Vertex buffer, so vertex count, index count, vertex buffers, indices. Vertex buffers pointers. So vertex buffer pointers, vertex buffer strides, vertex buffers offsets. Here, so the vertex buffers, vertex buffer pointers I. Oops, the vertex buffers. The vertex buffers I is this. Then the vertex buffers the vertex buffer pointers I is mesh dot vertex buffers I dot get. The strides is size of CPU mesh vertex buffers I 0. No, it's this. So it's the number of components per vertex times the number of bytes per component. Okay, so in this case, for positions, 3 components, 4 bytes per component, so it's 4, 8, 12 bytes. Okay, the stride is of 12 bytes. The offset is 0. So in this way, we can simply erase this. Obviously you need the like not vertex buffers. Here you need the index buffer. Here the index buffer, CPU mesh, index count, CPU mesh, indices 0, immutable index buffer, the subdress data is that, create buffer, and whatever. No positions, no UVs, vertex count, index count, vertex buffers, indices, fantastic. That's the move, the move constructor. Here is the move assignment. So release the existing resources, so positions, UVs, the indices, blah blah blah. So here it's basically this thing right here, vertex buffers, I dot release. Then so we release all the vertex buffers, and we also fix the bug in here. So we release the positions, the normals, the UVs, then we release the indices, we move the ownership. So the vertex count is other the vertex count, index count is the other dot index count, the positions here, so the index count, vertex count, index count, so the vertex count, the index count, the vertex buffers, and for that we need to do this, and here the vertex buffers, I equals std move other dot vertex buffers I. Not only that, but we also need the vertex buffer pointers I equals the other dot vertex buffer pointers I, the vertex buffer strides I equals other dot vertex buffer strides I, because we need to like copy, and the vertex buffer offsets I equals other dot vertex buffer offset, vertex buffer offsets. Yeah, I think that all this code is a liability. I think that all this code is in truth a liability, and I don't like it. I really don't like it, because it's very error prone. This is very error prone. boy. I'm thinking of like removing because this is like very error prone. This is very error prone, to be honest. Oh boy. Yeah. Let's just okay, that's it. Let's just comment better for the commit message something like finish mesh factor. Okay, and then we simply say yeah. Let's try and do so the constructors will delete std class let's see this point. std mesh auto mesh std unique GPU mesh, and here the mesh dot becomes mesh arrow. Oh lord. Mesh indices return mesh. This gets done, this gets done. Fantastic. Out. Voila. It's the same thing basically. So default delete the move constructor, delete the move assignment, and here when you import memory, we don't care about vector, we don't care about span, we don't care about string. So for memory std and when you call import you do this basically, and then bingo, auto model std make unique fantastic. And obviously something will break, yes, because this thing right here, we just have const GPU mesh pointer, CPU mesh. This is const CPU mesh pointer, CPU mesh. And here the CPU mesh will be CPU mesh. Tac, tac. Tac, 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 tac. If we do this, oops. Okay. I can't do it like that, but auto TMP I can do it like that. STD PTR STD PTR GPU mesh, and here is the same thing basically. We do the auto TMP. Auto is very useful in C++, very useful feature. It just saves me the hassle of typing a lot. Voila. And everything works like a charm. Fantastic. Way easier, way faster on the programmer's side. So wrap both GPU, CPU and GPU mesh classes into pointers for simpler code. Okay. Fantastic. Wonderful, wonderful. Now okay, now we can go to the next to-do on the list of to-dos. Add simple math. If should we generate raw wheel events or virtual wheel events? Oh, this is a very good idea. Very good. So as of right now, the input events log is kinda cringe because like, look at the wheel. What is this? Oops. Like, for later. going to get name. Fantastic. Okay, should we rename it? Okay, rename to get Rwanda. Makes sense. Dot row handle becomes dot get row handle. And everything should work like a charm. Yes. To do F8, F8, F8. Hard-coded, of course, hard-coded, of course, hard-coded, of course. Very temporary, yes. Generate maps, okay. Factor out RTS camera code. This should go into something like camera.update. Putting logic in here. Hard-coded. Start slot, yeah. Not very good, I don't like it. Set constant buffers. Why not use the same thing and be done with it? Here, F8. Implement a buffer map wrapper class that uses RAI. Yeah, this could be very useful because we do it a lot and it's quite some code for basically doing nothing. So we just fix some of those. The most important, I think, is the wheel, like the wheel events. The other ones are kinda meh, like not really that important, but still we need like this one is I think a good exercise. Also wrapping the simple math API, I think it will be quite good on like long term. We need a name. Yes. Apparently I need a name. Vector 3 float 3. This thing is quite annoying. Implement a buffer map wrapper class that uses RAI. So basically something that I create. When I create it, it calls the map. So something like a class buffer. subresource handle or map subresource public. For now, and then we want the copy constructor, delete it, the move constructor, delete it, and then copy assignment and move assignment, delete all of these. Now for the private part, well, we have our m mapped subres. Okay, subresource mapping, subresource mapping, here, usually auto-generate these, so it's oh my god. I need to do it like okay, let's do this. 11.h. Boom. Yeah. Okay. Yeah. Okay. Now. Provides access to subresource data. ID11 device context map gets a pointer to the data contained in a subresource. A pointer to the 3D11 mapped subresource structure. For the mapped subresource, see the remarks section regarding null pointers. let's sub-resource const return sub-res of the non-const variant, not really a problem. When you call map, here I need the device context. So context is the context, and sub-res, then we simply say context map and res for that. So now we just copy oh my, now we need the resource. We need the sub-resource. Sub-resource. We need the map type. We need the map flags. And we need the map the sub-resource, which is here, index number of the sub-resource IDX. Now all of these go here. Context, resource, sub-resource indexed map. So I simply map the H result plus check H. Win32 CKHR, sorry. sub-resource mapping. When oops, so we call the map, then we get the mapped sub-resource, we do our own thing, and then the context unmap this sub-resource to be unmapped. So invalidate the pointer to resource and renable the GPU's access to that resource. So the resource and the sub-resource. So we need sub-resource index. We need the resource and the sub-resource index. And thus this is the mapped sub-resource. Okay. Okay, so this is the context. This is the resource. This is the sub-resource index. The resource. And sub-res mapped sub-resource. Fantastic. And the thing right here, we do the unmap, which is basically mcontext unmap, and when you unmap you do the resource and the sub-resource. Voila. Fantastic. Now we have everything to do our and when we do this, we simply say A3V11 map sub-resource mapping sub-res mapping, and we pass the context, the resource, apart from this implement voila, no map, no unmap, sub-res mapping dot get sub-resource dot dot. fantastic. So here this goes away, and we call the subrest mapping. We simply do this, and then we do this, we do the mapping, and then we can forget about the unmapping. Booyah. Goodbye. Here there are all the things we want, and then the map, don't really care about it. The mapping, for the mapping we need the context and all the other stuff. We don't need this anymore. The map is called implicitly. The subres mapping.get the subresource. Do all your thing, and then say goodbye. Just to strain the fact that I need these parentheses. These are not just for show. I can even improve it further. Okay, everything looks kinda cool. Implement try handle for directory D11 subresource map unmap. Okay. Let's add here a to do implement texture class, implement CPU texture and GPU texture classes. Okay. Never call unmap and unmap again. So fantastic. Okay, add to do, and I think it's getting late, so I think I'll just wrap simple math. Yeah, and expose better API. This is a thing that should be done because I don't really like the simple math API. This is like, we don't care about it. This is important. We should tomorrow, I think. Hard-coded, very temporary. The RTS camera. This is important. Generate the maps. Implementing implement CPU texture and GPU texture classes, the maps, factor out RTS camera code, not really. They should go into something like camera update, game logic. Yeah, so the wheel, like the mouse wheel, this, then the this, so the CPU and GPU texture classes, and then wrapping the simple math classes, because it's not really that well. Another thing we should really care about is to find a way to use the same struct definition for both constant buffers on find a way to use the same struct definition for constant buffers, the same constant buffer struct definition from both HLSL and C++. Okay, this is another thing because this is very error prone. What I would like to have is just a single definition for our struct, for the constant buffer struct, basically, that acts, that can be used both on CPU, both like C++ side and GPU side, so HLSL side. I'm thinking like something like when we do the wrapping of our simple math, we can rename like the matrix like that, the matrix class, call it all lowercase matrix, and the vector classes call them like float3 or and float4, basically. I think that's a good kind of good idea. And then basically include these just the struct definition, both from the same, have a single header file with the struct definition, and then include that file both from C++ and from HLSL. Okay, that's something that we should do. Add to do. Everything obviously works fine. Here the ambient is oops. Ambient color, the sun color, looks like it's night. Well, okay. Yeah, some end of stream considerations. Have a good day and see you next time. Bye bye.